Okay, Bismillah ar-Rahman ar-Rahim. Now let's look at the changes in the constraint quantity values, the right hand side. And we can establish the value of the right hand side, which will tell us that how much we can change the right hand side without changing the solution variable mix. Remember that the corner point values will change by changing the right hand side value, but the variable mix, which means that those variables which are in the solution mix will remain in the solution mix, and those which are out of the solution mix will remain outside the solution mix, including the slack variables. So this is the idea. There is related to this concept is also the what we call it shadow price. The shadow price remains valid within the range over which we can change the right hand side values. So let's look at the same example. Same example of company making bowls and mugs, and we have the constraints here. We have made equality by adding slack variables S1 and S2, and this is our original solution at point P, which is x1 is equal to 24 and x2 is equal to 8. When these two variables are in, we have the slacks are both equal to 0, and z is equal to $1360. Now, by changing the right hand side, we are moving the constraint either upward away from the origin or towards the origin. By decreasing it, we move towards the origin, and by increasing, we move away from the origin. Now let's see that the first constraint x1 plus 2x2, which is this one, x1 plus 2x2 is equal to 40 here, and we are moving this constraint outward, and we want to see that how long this solution variable mix remains same. As we move away, we have another constraint line shown, which is parallel to this one. We have moved the right hand side from 40. We have moved 40 to 60, and since we have not changed the technological coefficients, the slope of the constraint remains the same. And since the right hand side only is changed, so with the same slope, the constraint has moved away from the origin as shown over here. This is the new constraint. x1 plus 2x2 is equal to 60 now. And when we move away from the origin, this point B start moving, and it has now the new point is B prime. Now you can see that we have a new solution here. x1 is equal to 12 and x2 is equal to 24, and of course the z will also vary because now we have a larger feasible region, and the profit will be increasing here. S1 and S2 is equal to 0. So we can see that both are in the solution mix, though both the variables are in the solution mix, and S1 and S2 are both 0. So the range, we are looking for the range when this changes, when x1 or x2 becomes equal to 0, one of them, and S1 and S2 may have some positive value, one of them. So by changing this, we will establish the range. As we can see that if we move further from x1 plus 2x2, the original constraint, is equal to 40 to 80, the point B, which was here, now we have a new point A prime, and the variable mix has been changed here. X1 is now equal to 0, x2 has some positive value, S1 is equal to 0 and S2 is equal to 0. So this is the range to which we can increase the value of the right hand side of the first constraint. Maximum we can change. On the other hand, when this constraint x1 plus 2x2 is equal to 40 is decreased to 30, we can see that point B now move to new point C here, and here we have x1 is equal to 30, x2 is equal to 0. Now one variable is now 0 and another has a positive value, and the two slacks are again 0, but we have a change in now. So this is the minimum Q1 minimum, the right hand side of the constraint. How we can establish that? We can do it by saying that we have the original constraint is x1 plus 2x2 is equal to 40. This was the, or less or equal to 40. We make it equals to Q1, and we want to establish the range of Q1. So what we are looking for is Q1 less or equal to or greater or equal to. These are the values we are looking for. We have seen that x1 and 2x2. All right. What we are looking for is now how much Q1 we can change. We have seen that as we move away from the origin, as shown in figure of this one A, we are moving away from the origin. The point B has shifted to A prime, where the new coordinates are x1 is equal to 0, x2 is equal to 40. If we put this value in this equation here, this equation, let's call it equation 1. If we put it in equation 1 here, then what we get is 0 plus 80 is equal to Q1. So this is the maximum, Q1 maximum, you can say that. Q1 maximum is equal to 80. All right, that's the maximum we can change. Now let's look at the lower side. The lower side, when we decrease this right hand side from 40 and keep decreasing it until this point B becomes to C, and the coordinates of C are x1 is equal to 30 and x2 is equal to 0. If we put this value in equation 1 again, we see that x1 is equal to 30 plus 0 is equal to Q1 minimum. So what we get is the 30 here. This is the range over which the variable mix remains same. After that, it changes. So the original value at x1 plus 2x2 is equal to 40. The solution mix both have x1 and x2 were both positive, and s1 and s2 were both 0. Now with changing to 80, we have x1 becomes 0 and x2 is equal to 40. and when we change it to the downward side, we get x1 is equal to 30 and x2 is equal to 0. So this is the range over which we can vary, and we will have the same actually solution variable mix. Also, another concept is the worth of the resource. The worth of the resource is called the shadow price. One unit of that resource is called the shadow price. So if this constraint, which is a labor constraint, if for example we have x1 plus 2x2 is equal to 41, we would like to see if we have one more hour of labor hour, how much the profit increase. That is called the shadow price, and this we can do it by resolving it, and what we get is basically that the it is increased to the value increases to $1376. Original was $1360, so the increase is by $16. $16 is the worth of this labor hour. We will see in Excel this thing. Now this is the second constraint, and if we want to establish what is the right hand side value, how much it can change is without changing the basis of optimal basis. Again, we move this by increasing. An original value was 4x1 plus 3x2 is equal to 120, and the optimal point is B. If we move, if we increase the value to, let's say, 160, we will see that the new point, it will start moving, point B will start moving until it comes to C prime. And that new point, we will have a new solution variable mix. We have x1 is equal to 14 and x2 has become 0. So by increasing from 120 to 160, we will have a new point. Similarly, if we move downward, decrease the value, right hand side value from 120 to new value 60, we will have a new corner point, which will be when we will be moving this constraint downward here. This B will start moving until it goes to this point A. And here the coordinates are x1 is equal to 0, x2 is equal to 20. So again, we can put this value. We have the original constraint is 4x1 plus 3x2 equals to, it was 120. We want to establish the range. We can change it to, let's say, call it Q2, second constraint, the right hand side quantity, and we want to see how much Q2 can change. So Q2, the new point over here from the graph, we can see that the coordinates are x1 is equal to 40 and x2 is equal to 0. If we put this value in the equation, let's call this equation 2, okay, then what we get is 4 multiplied by 4 is 40 is 160 plus 0, okay, plus 0 is equal to Q2, which is Q2 maximum. So what we get is Q2 maximum is equal to, if I write over here, Q2 upper range becomes 160, and the lower range will be, when we change from downward, we see that the point has moved from B to A, which has x1 becomes equal to 0 and x2 becomes equal to 20. So if we put this in equation 2, we get Q2 minimum equals to 3 multiplied by 20 is equal to 60. So here we have 60 here. So this is how we can establish the range of right hand side for any constraint. All right, now this is telling us the upper parts, there are two tables which we get in Excel sensitivity. When we see the sensitivity analysis, what we get is two tables. One is the table related to changing the objective function coefficient, and the second table what we get is related to changes in the right hand side quantity value of the constraints. So let's look at the first one. The first one is telling us that allowable increase is 40 plus 26.67. So if I may write it, C1, the upper limit is 40 plus 26.67 is 66.67, and the lower range is 40 minus 15 allowable decrease, which is equal to 25. Okay, and then the same way, if we have the C2, if we want to see the coefficient C2, we can see that it is C2 is 50 minus 50 plus 30 is 80 on the upper side, and on the lower side it is 50 minus 20 is 30. Okay, this is for the objective function coefficient in the first table. The second down table, we have the right hand side quantities are there. The right hand side quantity is 40 and 120, and the allowable increase and decrease are given. We can see from here that allowable increase is telling us that we can increase from 40 to 80. So we already have done it, Q1 80, and the lower side is 60. 40 minus 10 is 30. And the second Q2 is 120 plus 40 is 160, and 120 minus 60 is 60. So this is the range over which we can change. The shadow price remains valid within this range. Within this range, the shadow price, which is the worth of 1 unit of that resource, is called the shadow price or dual price or dual value. These are the different names, and they remain valid within this range, which means that if, for example, we have on the right hand side of let's say labor, we have 1 hour more, 40, instead of 40 hours we have 41 hours, our objective function will increase by $16. And if I may ask, for example, that a laborer comes and he says that he's willing to work for $10 per hour, then we can hire him because the worth of this resource is 16. If he says I'm willing to work for $20 per hour, should we hire him? The answer is no, because the worth of this resource is only 16. Now let's say that the laborers are there and they are willing to work for $10 per hour. Now the question is that we can hire them because they will bring more profit, but the question may be asked, how many should we hire them? And the answer comes from this allowable increase and decrease. This is a very good information from management point of view, because now they know that what is the worth of the resource and how much this worth is, how much we can increase the number of hours or number of pounds, etc., so that we can increase the profit. So allowable increase and decrease tells us the range over which these shadow prices are valid. This thing is telling us, final value is telling us that the right hand side was 40 and the final value is 40, and for the first constraint, and for the second constraint 120 and 120 again. It means that both the constraints are fully used up, and the slack is 0. When the slack is 0, we will have some positive value of shadow price, but when the slack is has some positive value, the shadow price of that resource where the slack is there, some positive value, it means the shadow price will be 0, because people are sitting idle, the resources are not used fully, and people are sitting idle, and the worth of that resource becomes 0. There's one thing which is not explained yet, is reduced cost. The reduced cost is, the concept is this, that how much the profit should be increased so that that product or that variable becomes into the solution mix. Now at the moment, both the products, bowls and mugs, are in the solution mix. So the profit, how much profit should we increase? It is 0, because they are already in the solution mix. If any of them is not in the solution mix, then we will get a reduced cost, and this reduced cost will be negative for maximization problem and positive value for minimization problem. Now here at the moment it's showing 0 0, but I will show you on the Excel that what if we change the values and one of the variable is not in the solution mix, then how do we interpret that? Okay, let me show you how we can model this in Excel, this linear programming, and solve it using solver. So what I have done is just filled up this product. This is okay, P should be, there are two P's here. Let me remove one of them. Okay, products, we said bowls and mugs we have, and profit per unit is 40 and 50. I just filled this up. Resources, we have two resources, labor hours per unit, and clay is in pounds per unit. This is telling us that 1 hour of labor is used to make one bowl, and 4 pounds of clay is used to make one bowl. Similarly, 2 hours of labor is used to make one mug, and 3 pounds of clay is used to make one mug. Here, this we will use it for filling the formula here, because what we are going to do is we have x1 plus 2x2. The constraint is x1 plus 2x2 less or equal to 40. This is the constraint. So what we will do is we will write down this the formula over here, which is x1 plus 2x2, and here we 4x1 plus 3x2 will be over here. These constraints we have just put it over here, less than or equal to. These are not the actual constraint used in solver. The solver has separate constraints. This is just to show symbolically that these are less or equal to constraints here. And this is telling us what the resources are available to us, 40 right hand side and the 120. Left over is the slacks, which is unused resource here. So we will give the formula here. Now bowls and mugs, we want the answers to be over here. Bowls is the number of bowls, how much, and number of mugs here. So these are our decision variables, like x1 and x2. These are our x1 and x2s are there, and this is our profit. All right. Now here we will give the what we call it, the formulas. This is our x1 and this is our x2. All right, number of bowls, number of mugs, x1 and x2, and this is 1x1 plus 2x2 should be over here. So we put equal to this multiplied by number of bowls, right, plus this which is the 2 hours multiplied by number of mugs. So this should be over here. We put this formula here, and same way the other formula, which is 4x1 plus 3x2. So here we will have equal to 4 multiply by number of bowls plus 3 multiply by number of mugs, and that's it. So these are the formulas here. And for profit also we should have 40x1 number of bowls plus 50x2, so equal to 40 multiplied by number of bowls plus 50 multiplied by x2. Just to check our formulas are correct, we just put 1 here to see if the formulas are correct. So our formula is correct. We can see the profit is 90 when we make 1 bowl and 1 mug. Then x1 is equal to 1 and x2 is equal to 1. Then 40 plus 50 is 90 here. And similarly over here we have when we make 1 bowl and 1 mug, we will use 3 hours of labor and 7 pounds of clay. Leftover. For leftover, this is the difference between the available and minus the usage. So equals to this minus usage will give us the slack. So at the moment, if we make 1 bowl and 1 mug, the slack is 37 hours of labor and 113 pounds of clay. All right, so now we are ready for solution. We go to data tab. Already we are in the data tab, and we see that in the analysis we don't have solver. So we go to file here and we go to options, and in the options we go to add-ins, and in the add-ins we have Excel add-ins. We say go, and here we have solver add-in. We just tick this one and say okay. So it's just taking a little time, and we got solver here in the analysis, what we call it, anyway, we got solver here. All right, now when we go to the solver, okay, I have put the profit where we want to get our answer. I just put this cursor here so that when I go to solver, it is the set the objective function, and it is saying C15. So I already put it at 15, is fine. We can change to maximum, or if it is a maximization problem or a minimization problem. Actually, it is already filled up. Yeah, because I solved it earlier. Anyway, we have maximization problem. Then by changing variable cells, the variable cells are the variable cells. We just click on that. These are the variable cells. Okay, and these are the 2 constraints. I remove them and then I can add them later. I can just delete these. and delete the other constraint also, just to show you how it is done. Now over here we say add, and it says cell reference. Cell reference is that usage, this one, which is x1 plus 2x2, which is this one, should be and less or equal to, this is the actual less or equal constraint, so in the solver, and the right hand side is the value 40 here. This is the cell, and we say add. So we have added. Now the second constraint we have to add is this one, and again it can be less or equal to, greater or equal to, we can change. In this case it is less or equal to, so there's no problem, we don't have to change. And the right hand side is G9 cell, and we say okay. So now both the constraints have been added. This one is click on this one, make unconstrained variables non-negative. We just tick this one so that this is a non-negativity constraint. Here we have GRG, nonlinear, simplex LP, evolutionary. We select the simplex LP here, and we just say solve. And as you can see that the solution is already there. We have 24 bowls, 8 mugs, profit is 1360. Now in this new window we have reports. We can generate of answer report, we can generate sensitivity report and limits report. The most interesting one, answer, is already we got it, so there's no need to have that report, but sensitivity report we would like to see. When I click on this one and say OK, we will get a new sheet. So when I say OK here, we got a sensitivity report here, and this is the sensitivity report which I showed you earlier in the slides. Let me make it bigger. All right, and we already have seen we know how to interpret this. We have final value is bowls is equal to 24, mugs is equal to 8, and this is we can change it if you like. We can just okay, this is bowls, and this is bowls also, just cosmetic here. And what we have is the coefficient 40 and 50. This is the actually final value. X1 is equal to 24, x2 is equal to 8, bowls is equal to 24, mugs 8, number of mugs, and this is the objective coefficients of this one, 40x1 plus 50x2. This is the allowable increase and allowable decrease. We have seen that earlier. I just put it again here. You can see that C1 upper limit is 66.67 and the lower limit is 25. All right, and then we have C2. C2 is 80, 50 plus 30, and we have what we call it, 50 minus 20 is 30. Let's look at the second table here, which is related to the right hand side. The right hand constraint right hand side is 40 and 120, and the final value is also 40 and 120, which is telling us that both the constraints are fully used up, which means that slack is 0. When the slack is 0, there will be a shadow price for that resource, where we have a positive value. We will have a positive value if the constraints are fully used up. So the shadow price is for the first resource is 16 and the second resource is 6. Allowable increase and decrease, we can just see that Q1 is less or equal to 40 plus 40 is 80, and 40 minus 10 is 30. This is the constraint. This is the right hand side, which you can vary without changing the solution variable mix. or without changing the shadow price. And the other one is Q2 is 120 plus 40 is 160 here, and the lower side is 120 minus 60 is 60 here. All right. Reduced cost, as I told you earlier, that if both the variables are in the solution mix, we will get reduced cost equal to 0. It will make sense when one of the variable is not in the solution mix. Now we know that the objective coefficient, if we change, for example, 40 from 40 to, let's say we make it 24, okay, up to 25, the solution final value will stay the same. But if we go below that, we will have no new corner point. So first I will show you that let's say we decrease this objective coefficient from 40 to 26 or 25.5 or something like that, and show that the final value stays the same. And then we will change it to something like 24 or 24.9, something like that, to show you that we will have a new corner point. And of course that will also show us reduced cost, because one of the variable will be 0. So let's go back and see the changes. Okay, now here we just I remove this, and what we do is we change the coefficient value, just to show you about the reduced cost concept and the ranges concept. Here, if we, for example, we change it to the minimum value of that was C1 was 25. So if we keep it 26, let's say, the objective coefficient make it 26, we should not change the corner point. So I will show you that. First we will do that. We make it 26 and we run the object solver again. Let's make this 0 0, just to show you that it is okay. Now we go to solver for solving and we say solve, and what we get is the same corner point. Bowles is equal to 24 and mugs is equal to 8, and we can see that it didn't change. The corner point didn't change when we changed the coefficient from 40 to 26. Now if we change to 24, let's cancel this out and let's change to 24. Now we know that it is out of the range. We will have a new corner points. Let's see. Go to solver and we say solve, and we have a new corner point which is 0. Bowles is equal to 0, mugs is equal to 20. The corner point has changed. X2 is now 20, X1 is equal to 0, and this we got a new corner point. Let's see the sensitivity of this one. Sensitivity analysis, go to this and I will show you the reduced cost now. We say OK, and we have a new sensitivity report here, and let me get it bigger. Right, now we see that when final value over here has become 0 of Bowles, and the objective coefficient is 24, it is the reduced cost is telling us -1. Reduced cost -1 means that the profit, if we increase the profit by $1, okay, reduced cost -1 means increase the profit by $1, we will have a new solution mix. We will have of course the bowels will come into the solution mix. All right, which is telling us that if the objective coefficient is increased by $1, all right, then we will have the variable bowels, number of bowels will be in the solution mix. At the moment it is not in the solution mix, it's 0. So that is the idea of reduced cost. Also interestingly, we can see the allowable decrease here and allowable increase here, which is giving us infinities. Allowable decrease is minus infinity. If I may write it down, the new values, it is telling us that C1 now, the upper value is increase is 25, and decrease, we can decrease to minus infinity. This 10 raised to power 30 is actually allowable decrease is minus infinity. So we can decrease the profit to minus infinity, and the corner point is not gonna change, which is 0 and 20. And same way, if we look at the C2 here, C2 is telling us that we can allowable increase is 10 raised to power 30, which is infinity in Excel. So it is infinity here and less or equal to, and make it 48. So within this range now, this corner point, which is the new corner point, is not gonna change. Okay. We can also see that the shadow price have been changed as well. The shadow price of labor is now $25 per hour, and the clay is now 0. Why it is 0? Because you can see that the final value is 60 and the right hand side is 120, which means that 60 hours are unused hours. So when unused hours are there, or not, this one is clay is there, so unused clay is there. 60 pounds of clay is not hours, it is, okay, 60 pounds are unused, and the ranges of them are now for right hand side quantity 1, the upper range is 40 plus 40 is 80, and 40 minus 40 is 0, and Q2 is we can increase to infinity and decrease it to 120 minus 60 is 60. Okay, within this range the shadow price is valid, and this makes sense. Let's see, for example, Q2. Q2 is already, it is telling us that the shadow price is 0. So if we keep increasing the right hand side from 120 to infinity, the shadow price will remain 0. Right? Makes sense. And the shadow price of the other resource is 25, within the range from 0 to 80. Let's go back to the original problem here, bowls and mugs, and we have shown you that how these things work. Now I will show you the fertilizer problem, the problem of minimization. So here we have a fertilizer problem, minimization problem. We had remember that we have done this earlier in chapter 2. We had 2 fertilizers, Supergrow and CropQuick, and the bags of Supergrow, one bag of Supergrow is $6, and the one bag of CropQuick is $3. All right, and we already have actually solution here. The 2 resources were what we want actually to be put on as a nutrient in the land where we are putting these fertilizers. We want 2 nutrients, nitrogen and phosphate. and the requirement for the land was 16 pounds and 24 pounds, or 16 pounds of nitrogen and 24 pounds of phosphate. And this was in pounds, these were in pounds, 2 per bag. So 2 pounds of nitrogen was there in Super Grow, all right, and 4 pounds of phosphate was there in Super Grow. And then in the Crop Quick, the other fertilizer bag, 4 pounds of nitrogen was there and 3 pounds of phosphate was there. All right. The result has shown us that we will have leftovers is minus 16, negative slack is actually surplus. So we will have a surplus of 16, which means that although the minimum requirement is 16 pounds, we have already a surplus there, okay, in the optimal solution. And the minimum requirement for phosphate was 24, and the usage is also 24. There is no surplus here. The optimal says also that it is 24. Now I show you the sensitivity report of this problem. Here is the sensitivity report. This is the objective coefficient, $6 and $3. Bags of Super Grow cost $6, and bags of Crop Quick cost $3. The final value tells us that we buy only Crop Quick, which can meet the requirement of nitrogen and phosphate, and the final value is bag of Super Grow is 0 and 8 bags of Crop Quick are needed. This is the allowable increase and decrease of this the coefficients of the cost. And what we have is that it's telling us reduced cost here. The reduced cost is telling us that if you decrease the cost from 6 to 4, okay, then we will have the bag of Super Grow will be there, and we will have a new solution point. So this reduced cost is there. Okay. We can write down the range of the coefficients. C1 is telling us that allowable increase is for the first one is up to 30, infinity, 10 raised to the power 30, and it can be reduced to 4. Okay, and for C2 we have the upper is 4.5, and 3 minus 3 is equal to 0. All right. Now you can see that the first one is making sense because the cost is already high and this is not in the solution mix. So if we keep increasing the cost up to infinity, the solution mix is not going to change. Let's look at this one, the second table, which shows the shadow price and the constraints right hand side and the final value. We can see from there that there is a surplus, where the right hand side was 16 nitrogen usage, and the final value is now 32, which means that we have some surplus there. And the phosphate right hand side was 24, and the usage is also 24. The shadow price is 1. Shadow price is 1 for phosphate. So which means that if we make the requirement of the land not 24 but 25, the price, the shadow price is 1, so it will increase the cost by $1. Again, looking at the right hand side ranging, we can say Q1 we have 16 plus 16 is 32 here, and allowable decrease is we can decrease up to minus infinity. And then for Q2 the upper range is we can increase it to infinity, right, and decrease it to 12. 24 minus 12 is 12. Again, it makes sense here. For look at the quantity side here, we already have 16 surplus. Okay, 32 is there, so 16 surplus is there. If we keep increasing this resource, it will have no effect, and the surplus, I mean the sorry, it not keep increasing. We can increase up to 32. Surplus is 32, and then if the requirement is more than 32, then it will have some shadow price. On the other hand, we have the quantity on the right hand side of phosphate. We have 24, and we can keep increasing if the requirement is more, let's say 30, 100, whatever. This shadow price will be valid there. All right, so this is about the fertilizer here. Okay, I think I can stop it here for a while.